So when you write generic equation for acid equilibrium, so let me write an acid equilibrium reaction for generic acid HA. So HA in aqueous form, and it reacts with H2O liquid, and it is in equilibrium with H3O plus aqueous and A minus aqueous. So this is the simplest acid-base equilibria. This is the simplest acid-base equilibria in which weak acid or weak base reacts with water. So now let's say we are defining, when we write constant, acid ionization constant Ka, that's called acid ionization constant. So whenever we write equilibrium, you can see equilibrium constant, these are their products. So, and they are in aqueous forms, right? So what we learned last time, H3O plus product concentration, A minus product concentration, divide by HA, that's in aqueous form. So HA, that's how we write. Now liquid water, we do not include in equilibrium constant expression. This one we do not include in here. We do not include because it's in liquid form, right? So that's the equilibrium expression we learn how to write, but for acid ionization Ka, and if it is generic equation, and then you can write it. Now I'm going to give you let's say one example, and see if you can write it. Let me see. I can find okay. Alright, so I'm going to give you one equation, and then we are going to work on how to write ionization constant, acid ionization constant. Alright, so let's see, we have HC6H5O plus H2O, which is in equilibrium with H3O plus and C6H5O minus 1, and here these two products are in aqueous. H2O is in liquid form and this is in aqueous. Now, when you compare with the generic equation, let me write. When you compare with the generic equation, this is HA, weak acid. This is water in liquid form. You get H3O plus and than A minus 1 when you compare it, right? Now when you write Ka, acid ionization constant, for this reaction, we know that product concentration H3O plus ion C6H5O minus 1 and divide by H C6H5O. So that's how we write acid ionization constant for this equation. Okay, so that's the basic. First, how to write acid ionization constant expression.